You know the feeling, right? You pull out your phone, you open up a map, and boom, there it is. A little blue dot that tells you exactly where you're standing on planet Earth. We do it all day, every day, and we barely even think about it.
But have you ever actually stopped and wondered how that happens? I mean, really, how does that little device in your hand know its precise location with such mind-blowing accuracy? It's a pretty cool question, and the answer is going to take us on a journey from your pocket all the way up into deep space.
So let's start right there, with that dot on the map. That simple, little blue circle that keeps us from getting lost. Well, that's the finish line of an absolutely incredible relay race of information.
And what's just wild is how precise it is. We're not talking about it knowing what city you're in or even what neighborhood. No. Your phone can find its spot on the globe to within just a few meters. Seriously. That's the difference between standing on the sidewalk and standing in the middle of the street. And it does all of this in just a few seconds. It's amazing.
Now, here's the secret. The real magic isn't actually happening in your phone. To get how this works, we need to look up. Way up. The answer is coming from what you could call whispers from orbit, a constant chatter of information from this huge satellite network.
Right now, circling our planet, there's this whole constellation, a network of more than 30 global positioning system satellites. It's this massive, totally invisible web of technology hanging right over our heads.
And they're not just kind of floating up there. These satellites are 20,000 kilometers away. That is a distance that is almost impossible to wrap your head around. I mean, think about it. That's like driving from New York to LA and back, twice. And they're up there, right now, just doing their thing. And these satellites aren't just sitting there. They are constantly talking, beaming these tiny radio signals down towards Earth, basically blanketing the entire planet in this grid of pure information.
So what's actually in these little whispers from space? Well, each signal is like a tiny, super-fast postcard with two critical pieces of information on it. First, it says exactly where that satellite is in its orbit. And second, it has a timestamp for the precise moment the signal was sent, all thanks to an atomic clock on board that is accurate down to the nanosecond.
Now your phone, in this whole cosmic conversation, isn't a talker. It's just a listener. It has this little receiver inside that's always listening for these signals. It's not sending anything up to space. It's just quietly grabbing these messages from at least 4 different satellites at any given time. Okay, so your phone has these postcards from space. Now what? How does it turn all that data into a location? Well, this is where a really clever bit of geometry comes in, something I like to call the 3-circle trick.
The official name for it is trilateration. And I know, that sounds super complicated, but the idea behind it is actually beautiful and simple. All it really means is that if you know how far you are from a few known points, you can figure out your own position. So the key is this. Your phone has to figure out exactly how far away it is from each of those satellites. And this is exactly how it works. First, your phone gets those signals we talked about. Then it looks at the timestamp in the signal and compares it to its own clock. That tiny difference in time, that's how long the signal took to travel from the satellite to you. And since we know the signal travels at the speed of light, which is a constant, your phone does a quick little calculation. Distance equals speed times time. And that's it. It now knows its exact distance from that one satellite. And it does this for multiple satellites all at the same time.
Okay, let's picture this. Imagine your phone calculates it's exactly 20,000 kilometers away from one satellite. Well, that doesn't put you in one spot. It means you could be anywhere on the surface of a gigantic invisible sphere, with that satellite sitting right in the center. But now, let's add the signal from a second satellite. You get another giant sphere of possibilities. And where do those two massive spheres overlap? They intersect to form a perfect circle. So, just like that, we've gone from an infinite number of points on a sphere to an infinite number of points on a circle. See? We're getting closer.
And here's where the magic happens. A third satellite gives you a third sphere, and that third sphere will cut through that circle at exactly one point. And that point, well, that's you. That's your phone's location. A fourth satellite signal is then used to sync up the clocks and correct for any tiny errors, which makes the whole thing even more accurate. So, that's the whole cosmic geometry lesson. Now let's bring it all back down to Earth, from the vastness of space right into the palm of your hand. Let's talk about the space tech in your pocket. I mean, really think about this for a second. Every single time you check for directions, or look for a coffee shop nearby, or share your location with a friend, this entire incredible calculation is happening. Your phone is having this super fast, invisible conversation with satellites 20,000 kilometers away,
all just to put that little blue dot on your screen.
It really is a kind of everyday magic, isn't it? A whole symphony of orbital mechanics and physics, with signals zipping along at the speed of light, all working together perfectly. And hey, get this, because time actually moves just a tiny bit faster for the satellites in orbit, the system even has to account for Einstein's theory of relativity to stay accurate. So the next time you see that blue dot pop up on your map, just remember what it really is. It's not just a point on a screen, it's the result of a whisper